Alright, welcome to today's class. In today's class, we'll be dealing on height of a ceiling physics practical, height of a ceiling. Before we proceed, if you've not subscribed to our channel, kindly subscribe now and also ensure you like this video. Alright, so height of a ceiling. The aim of this practical is to determine the height h of the ceiling of a room using a simple pendulum. Alright. Alright, so this is the table. For the first column here, we have h measured in centimeter. We have 10, 20, 30, 40, 50, 60, 70, and 80. And here we have T1 and T2, both measured in seconds. Alright, so our major task here is to find the values of mean t, period t, and t square. So how do we find the value of mean t? Mean t is equal to t1 plus t2 divided by what? Divided by 2. So for the first one, let's find the mean t. We have 46.00 for t1 and t2 46.00. So we have 46.00 plus 46.00. All divided by what? All divided by 2. So 46.00 plus 46.00 divided by 2 is 46.00. Alright, let's consider the second one. We have 44.00 and 44.00. 44.00 plus 44.00. All divided by what? All divided by 2. So if you punch your calculator, it would give you 44.00. Alright, let's consider the third one. We have 42.00 and 42.00. 42.00 plus 42.00. All divided by what? All divided by 2. So if you punch your calculator, it would give you 42.00. Alright, let's consider the fourth one. For the fourth one here, we have 40.00 and 40.00. 40.00 plus 40.00. All divided by what? All divided by 2. So if you punch your calculator, it would give you 40.00. Alright, let's consider the fifth one. The fifth one here is 38.00 and 38.00. So we have here 38.00 plus 38.00. All divided by what? All divided by 2. So if you punch your calculator, it would give you 38.00. So let's consider the sixth one. The sixth one here is 36.00 plus and 36.00. So we have 36.00 plus 36.00, all divided by what? All divided by 2. So if you punch your calculator, it would give you 36.00. Alright, so the seventh one here is 34.00 and 34.00. 34.00 plus 34.00, all divided by what? All divided by 2. If you punch your calculator, it will give you 34.00. This is the seventh one. Alright, let's consider the eighth one. We have here 32.00 and 32.00. 32.00 plus 32.00, all divided by what? All divided by 2. So if you punch your calculator, it would give you 32.00. Alright, let's now write the values. We have here 46.00, and then the second one is 44.00. The third one is 42.00. The fourth one is 40.00. The fifth one is 38.00. The sixth one is 36.00. The seventh one is 34.00. And the eighth one is 32.00. Alright, our next task is to find the period t. So how do we find the period t? Alright, so period t is equal to mean t divided by number of complete oscillations. Number of complete oscillations. Number of complete oscillation. Alright, let's check the number of complete oscillation. Alright, let's check the method. Adjust the pendulum from the ceiling so that its bulb is about h equal to 10 cm from the floor. Record the exact value of h and measure the time for 10 complete oscillations. So we have the number of complete oscillations is 10. So therefore, period t is equal to mean t all over 10. So since period t is equal to mean t all over 10, let's now find the period for each of them. Alright, for 46.00, period is equal to, for 46, we have that 46.00 divided by 10 is equal to what? 46.00 divided by 10, if you punch your calculator, it would give you 4.6. And then the second one is 44.00. So we have here 44.00 divided by what? 10. It would give you 4.4. What's the third one? The third one is 42.00. So we have here 42.00 divided by what? 10. It would give you 4.2. Alright, so what's the fourth one? The fourth one here is 40.00. So we have here 40.00 divided by what? 2. Divided by 10 rather. So it would give you 4.0. So what's the fifth one? The fifth one is 38.00. So we have here 38.00 divided by what? 10. So it would give you 3.8. The sixth one should be 36.00. So if you divide it by 10, it would give you 3.6. And then the seventh one should be 34.00. If you divide it by 10, it would give you 3.4. And then finally, the eighth one should be 32.00. So if you divide it by 10, what will it give you? It would give you 3.2. Alright, at this point, we can now write the values. The first one gave us 4.6. So we write here 4.6. The second one gave us 4.4. The third one gave us 4.2. The fourth one gave us 4.0. The fifth one gave us 3.8. The sixth one gave us 3.6. The seventh one gave us 3.4. And then the eighth one gave us 3.2. Alright, our next task here is to get the value of t square. Period is t. So for you to get t square, just raise each of the numbers here to power 2. So 4.6 raised to power 2 would give you what? Let's say 4.6 raised to power 2. It would give you 21.2. So let's write it down here. 21.2. The next one is 4.4 raised to power what? 2. It would give you 19.4. So you write down here 19.4. The third one is 4.2 raised to power 2. It would give you 17.6. So you write down here 17.6. The fourth one is 4.0 raised to power 2. It would give you 16.0. So write down here 16.0. The next one is 3.8 raised to power 2. Our answer becomes 14.4. So write down here 14.4. The next one is 3.6 raised to power 2. So we have 13.0 as our answer. So write here 13.0. And also we have 3.4 raised to power 2. It would give you 11.6. So you write here 11.6. And then finally we have 3.2 raised to the power what? 2. Our answer is 10.2. So you write here 10.2. All right, let's now erase this. All right, at this point, we've gotten all the values that we need. Let's now look at the next page. All right, so this is the next page. It says, from the table, plot a graph of h against t square. All right, we are asked to plot a graph of h against what? T square. H against t square. H is the first column, and then t square is the last column. All right, so we are asked to plot a graph of h against t square. Now, since it is h against t square, h is known as the vertical axis. H becomes the what? Vertical axis. And then t square becomes the what? Horizontal axis. T square becomes the horizontal axis. All right, so the first task is to write the title of the graph. The title of the graph. And the title of the graph should be graph of h against what? Against t square. So this should be the title of your graph. H against t square. All right, so our next task is to get the scale of the graph. To get the scale of the graph. All right, so I'm going to show you what a graph looks like. All right, so this is a graph. Now take note of this. In a graph, you have the graph is designed in boxes, small boxes. All right, so a graph is designed in boxes. So take note of this. Each box is 1 unit. Each box is what? 1 unit. And each box is 1 cm. Each box is what? 1 cm. You can confirm with your meter rule. Measure each box in a graph. It would give you 1 cm. And 1 cm is 1 unit. So therefore, it is left with you to choose your scale. Everybody's scale cannot be the same. All right, so this is our scale. This is the scale I chose. Let 1 unit. Let 1 unit represent. Let 1 unit represent 1.0 second square on t square axis. So that's what I chose. Let 1 unit represent 1.0 square on t square axis. and what? And let 2 units represent 10 centimeter on what? H axis. Let unit represent 10 centimeter on H axis. So this is how to write your scale. Remember, before you start plotting a graph, the first thing you should do is to write the title of the graph. And after the title of the graph is to get your scale. Get the scale of the graph. And I chose 1 unit for 1.0 second square on T square axis. And then 2 units for 10 centimeter on H axis. Remember, everybody's scale cannot be the same. It is your choice. Alright, so this is the graph. This is a plain graph. This is H axis on the vertical. And then this is T square on the horizontal. Alright, so after drawing your axis, the next thing to do is to scale your axis. Remember, for T square axis, I chose 1.0 for 1 unit. 1.0 for 1 unit. Let's look at it very well. Each box is 1 unit. So from 0.0 to 1.0 is 1 box. So 1 box, which is 1 centimeter and which is also 1 unit, represents 1.0 second square. So we have here 1.0, 2, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0, 8.0, 9.0, 10.0, 11.0, 12.0, 13.0, 14.0, 15.0, 16.0, 17.0, 18.0, 19.0, 20.0, and 21.0. For H axis, I said let 2 units represent 10 centimeter. Remember, each box is 1 unit. So we have here 2 units for 10 centimeter. So we have 10, 20, 30, 40, 50, 60, 70, and what? 80. Alright, having scaled your graph, the next task is to get your point and then draw your line of best fit. Get your point and draw your line of what? Best fit. Alright, so what's the line of best fit? Look at my cursor. The line of best fit is the line that joins majority of the dots together. Majority of the dots together is called the line of what? Best fit. Alright, so what's our next task here? Having plotted the graph of H against what? T square. Our next task here is to transform the equation T equal 2 pi square root of H minus H all over G, so that H becomes the subject of the formula. So we are asked to find H from this formula. Alright, let's now find H. In the formula, we are told that T is equal to 2 pi square root of capital letter H minus small letter h all over what? G. And we are asked to find H. So how do we get H? Our first task here is to eliminate this square root. And to eliminate the square root, you simply square both sides. Simply square both sides. So if you square both sides, let me write it down. Square both sides. So if you square both sides, you would have t square is equal to, open bracket, 2 pi square root of capital letter H minus small letter h all over g, and then all raised to power what? 2. So t square is equal to 2 raised to power 2 pi raised to power 2, and then if you look at this 2 cancels the square root. 2 cancels the square root. So we have here capital letter H minus small letter h all over what? G. So t square is equal to what? 2 raised to power 2 is 4. And then pi raised to power what? 2. Open bracket, capital letter H minus small letter h all over g, and then close the bracket. So this can also be written as t square is equal to 4 pi square, open bracket, capital letter H minus small letter h all over g. Alright, so at this point, our next task is to cross multiply. Cross multiply. Alright, so if you cross multiply, you would have 4 pi square, open bracket, capital letter H minus small letter h is equal to gt square. Alright, so since we are looking for the value of small letter h, we simply divide both sides by 4 pi square. So we have here 4 pi what? Square. And then 4 pi square. So 4 pi square here cancels 4 pi squared. So we are left with capital letter H minus small letter h is equal to gt squared all over 4 pi square. So we are looking for small letter h. So we simply move small letter h to the right hand side. So we have here capital letter H is equal to gt square all over 4 pi square, and then plus small letter h. Now let's make small letter h the subject formula. So small letter h is equal to capital letter H minus gt squared all over what? 4 pi squared. Alright, so this is the formula for h. So therefore, h is equal to capital letter H minus gt squared all over what? All over 4 pi squared. So this is the formula for small letter h. Alright, it says, hence, the slope of the graph of h against t squared is equal to what? We are asked to find the slope of the graph plotted. Alright, to get the slope of the graph, you need to find a point such as this. A point such as this. A point where the line of best fit, the horizontal line and the vertical line meet together. A point where line of best fit, the horizontal line and vertical line meet together. So this is the kind of point we are looking for. Where this is the line of what? Line of best fit. So let's check the graph. All right, so this is the graph. This is the graph. If you look at the graph very well, you can see that the line of best fit, the horizontal line, and the vertical line meets at this point. They all meet at this point. So we mark this point. Let's come down. If you look here too, you would see that the line of best fit, the horizontal line, and the vertical line, they meet at this point. So you simply mark the point and then you draw your triangle. You bring down this line and you bring this line and let them meet at a particular point. From here, it forms a what? A triangle. It's more like a triangle, a right-angled triangle. So you draw your line down, you trace it down to your t-square axis for the first point, and for the second point, you trace it down to your what? Your t-square axis. For this one, you trace it down to your what? You trace it down to your what? H-axis. And this other one too, you trace it down to your h-axis. I've already traced it. All right, we are asked to find the slope. So take note of this. Slope is equal to change in vertical axis, and our vertical axis is h, all over change in what? Horizontal axis. Our horizontal axis is t square rather. So our slope is change in h divided by what? Change in t square. All right, let's take a look at the graph again. For h-axis, the side or the point closer to the origin is called h1. And then the point far away from the origin is known as h2. For t-square axis, the point closer to the origin is known as what? T-square 1. And the point far away from the origin is known as t-square 2. So from our graph here, we have that t-square 1 is 11 and t-square 2 is 20. h1 is what? 15 from the graph. And then h2 gave us 73. Remember, slope is changing h. So we have h2 minus what? h1 all over t square 2 minus what? T square 1. So our slope is equal to, what's the value of h2? h2 gave us what? 73. And then minus h1 gave us what? 15. All over t square 1, t square 2 rather, gave us 20 minus t square 1 gave us 11. So 73 minus 15 is what? Is 58. And then divided by 20 minus 11 is what? 9. So 58 divided by 9 is what? So therefore our slope M is equal to what? 58 divided by 9 is 6.44. Now remember that H is measured in what? Centimeter. And then T square is measured in second square. So therefore, the unit of our slope is centimeter per second square. All right, so the slope is what? 6.44 centimeter per second square. All right, so let's look at the third question here. Write down the measured value slope of the graph. So therefore, from what we've calculated so far, the measured value of the slope of the graph is 6.44 centimeter per second square. All right, the fourth question here says, write down the measured value of h-intercept. The measured value of what? H-intercept. So how do we get h-intercept? Now take note of this. Assuming this is h-axis and this is what? T-square axis. So here we have h-axis. Let me write it well. We have h-axis. And this is T-square axis. This is T-square axis. Now, and you have your line of best fit. Your line of best fit goes like this. Take note of this. The point where the line of best fit meets with the h-axis rather is known as your h-intercept. The point where your line of best fit crosses your h-axis is known as your h-intercept. So let's call here h-intercept. There is known as h-intercept. So let's confirm from our graph. All right, so you can see that our graph is not big enough for us to know the value, the exact value of h-intercept. So when drawing your own graph, please use a smaller scale or a bigger graph so you would know the exact value of h-intercept. So this is where our line of best fit stops. Check my cursor. This is where the line of best fit stops. So the graph is not big enough. And this is where h-axis stops. So if I had used a big graph, I would have known the exact value of h-intercept. So take note of this. Wherever your line of best fit crosses the h-axis, the point there is known as your h-intercept. All right, so at this point, let's assume that our h-intercept is equal to 135 centimeter. It's an assumption. Assume that your h-intercept is 135 centimeter. Mind you, when drawing your own graph, please try as much as you can to get the exact value of h-intercept. This is not the exact value of h-intercept. I had to assume a value because our graph is not big enough. All right, let's look at the fifth question here. It says the value of G deduced from the graph. So what is the value of G deduced from the graph? All right, so we are going to use this formula again. T is equal to 2 pi square root of h minus small letter h all over G. All right, so we have here T is equal to what? 2 pi square root of capital letter H minus small letter h all over G. Remember I told you, in order for you to eliminate the square root here, you have to square both sides. So if you square both sides, you will have T square is equal to, open bracket, 2 pi square root of capital letter H minus small letter h all over G, and then all raised to power what? 2. So this gives us T square is equal to 2 square and then pi square, open bracket, capital letter H minus small letter h all over G. Now remember, this power cancels what? The square root. So we have here T square is equal to 2 raised to power 2 is 4. And then pi raised to power 2, open bracket, capital letter H minus small letter h all over G. And then close the bracket. Alright, so this can be written as T square is equal to 4 pi square, open bracket, capital letter H minus small letter h all over G. So at this point, we are going to cross multiply. So if we cross multiply, we would have GT square is equal to 4 pi raised to power 2, open bracket, capital letter H minus small letter h, and then you close the bracket. Alright, so since we are looking for the value of G, we simply divide both sides by T square. If you divide both sides by T square, T square cancels T square. So therefore G is equal to 4 pi square, open bracket, h minus small letter h all over T square. Alright, so this can be written as G is equal to 4 pi square, open bracket, change in h all over what? T square. This can be written as this. Now recall that slope is equal to change in h all over what? T square. Slope is equal to change in h all over T square. So therefore G is equal to 4 pi square, open bracket, slope. Remember that slope M is equal to 6.44. Our slope gave us 6.44 centimeter per second square. So at this point, we are going to substitute the value of slope. So G is equal to 4 multiplied by, what's pi? Pi is 3.14. And raised to power 2 multiplied by what? What's the value of our slope? 6.44. So kindly punch your calculator. 4 multiplied by 3.14 square multiplied by 6.44. So therefore G is equal to 253.9. So what's the unit of G? G is measured in centimeter per second square. So this is the value of G. Let's write it down. So the deduced value of G from the graph is 253.9 centimeter per second square. Alright, so please don't copy my exact value and write it in your graph. Try as much as you can to calculate your own so that you would know how to prove all these formulas. Alright, let's look at the 6th question here. It says, find the standard error in G. Find the standard error in G. Let me erase this. All right, take note of this. Standard error. Standard error is equal to error minus exact. Error minus exact all over exact. So this is the formula for standard error. Standard error is error minus exact all over exact. But if you find out that your error is less than the exact, simply use exact minus error. If your error is less than your exact, simply use standard error is equal to exact minus error. All over exact. There are two things involved. If your error is greater than your exact, your standard error becomes error minus exact all over exact. But when you find out that your error is less than your exact, simply use standard error is equal to exact minus error all divided by what? Exact. All right, let's confirm the value of G. No, number 5, the value of G is 253.9. G is equal to 253.9 centimeter per second square. Remember, what's G called? G means acceleration due to what? Gravity. That's what G is called. So the general value of acceleration due to gravity is equal to 980.67. That's the original value of acceleration due to gravity. And the unit is centimeter per second square. So at this point, we are going to write exact. Exact. And here, this is what? Error. This one is called error. This is the error, the one we calculated. And the exact is the general value of acceleration due to what? Gravity. All right, so since we've gotten the value of the exact and the error, let's now find the standard error. All right, so if you look at the two values, you would see that the acceleration due to gravity we calculated for, which is called error, is less than the exact value of acceleration due to what? Gravity. And I told you that if the error is less than the exact, therefore acceleration due to gravity is equal to exact minus error, all divided by what? Exact. So therefore standard error is equal to what? What's the exact? Exact is 980.67. And then minus the error is 253.9. All divided by what? The exact. So we have 980.67. So kindly punch your calculator. So it will give you what? 980.67 minus 253.9. So it gives us 726.77. All divided by what? All divided by 980.67. So if you divide 726.77 by 980.67, it would give you standard error equal to 0.74. So that's the value of standard error. All right, so let's write it down. All right, so the value of standard error in G is equal to, we have 253.9. You will write the calculated value of G first, and then plus or minus, you write the value of the standard error, which is 0.74. And then open up a bracket, and then you write limit standard error, limit S what? SE, and then close the bracket. So what's the unit of what? The unit of standard error, or unit of G? So we write here centimeter per second square. All right, at this point, let me erase this. All right, so we've gotten the value of what? The standard error. So at this point, we are going to answer the questions here. The first question says, what does h-intercept represent? What does h-intercept represent? All right, so this is the answer. H-intercept represents the height of what? The ceiling. And then for the second one, explain why the graph does not pass through the origin. That's II. The answer is, it does not pass through the origin due to human/personal error, air resistance, and friction in the pendulum support. III. State two resources of error and precautions you took to minimize them. The answer is error due to parallax. Error due to parallax. It was minimized by timing more than one oscillations and taking the average. I also ensured all instruments were properly aligned and set up before use. Alright, in conclusion, the experiment was successfully carried out. All formulas derived were also proven to be correct. A graph of h against t square was plotted properly, and the slope is 6.44 centimeter per second square. The intercept on h-axis is 135 centimeter, and errors like human error, air resistance, and friction caused the graph not to pass through the origin. Alright, take note of this. When writing your own conclusion, ensure that you state the slope, your h-intercept, and the errors that you found when carrying out the practical in your conclusion. Alright, at this point, we have come to the end of this tutorial. If you've not subscribed to our channel, kindly subscribe now. Ensure you like this video, and you can also share this video to your friends and colleagues. If you have a question, please leave your question in the comment section of this video. And if you want me to teach another practical, kindly leave the title of the practical in the comment section of this video. See you in our next class.